Alright, for this video we're jumping to chapter 5. You can see we have in the notes 5.1 and 5.2. We have 1 and 2-step inequalities. You can see I already have this written down here. Hopefully you can read this. I know my writing is a little sloppy here. But I have our goal is the same exact goal when we solve equations. You want to isolate the variable. You want to get it by itself. I'm not going to go over a whole lot of these problems on here because really you guys have seen this before and you know all the steps in the procedure to get a variable by itself. The only difference is you can see all of these, like number 1, number 2, all of these, instead of having an equal sign, now they have an inequality symbol. There's only one little difference when you solve an equation and rather than when you solve an inequality. Here's the difference. I'm just going to put this like right up here. I'm going to put two numbers. I'm going to put 2 and 4. Okay. Obviously, I know these are not equal to each other. If I had to put, I'm going to put a little question mark. And if I had to put an inequality symbol between them, well, I know that 4 is bigger than 2. So I'm going to erase this question mark. And remember, since 4 is bigger than 2, the open part faces the 4. I don't know if you ever learned, the open part or the mouth eats the bigger number. Well, that's what's happening here. So this is read as 2 is less than 4. Now what I'm going to do to both sides of the inequality, to 2 and 4, I'm going to divide both of these by -1. And this is going to lead us to our one difference between an equation and an inequality. When I divide each of these by -1, well, 2 divided by -1 is -2. And 4 divided by -1 is -4. Now if I look at these numbers and I ask myself which one's bigger, it actually changes around. -2 is bigger than -4, so we actually have to reverse the inequality symbol. Okay, and the same thing would have happened. Let's say I erase the bottom here. Let's say I originally took the 2 and multiplied it by -1. Well, I still get the same thing, -2. Likewise, if I take the -4 and multiply it by -1, I still get the same thing in -4. Here's the big thing, the inequality symbol still switches. Alright, so that's one of the only things we have to remember. This is a key rule. I would squeeze this in the top. When multiplying or dividing both sides of an inequality by a negative, okay, so let's write this. I'll abbreviate some of it. When multiplying or dividing both sides by a negative, sorry for the sloppy handwriting. Okay, when you do that, like I did in that case with 2 and 4, you have to switch the inequality symbol. Okay, so I'll abbreviate inequality. That's good enough. So switch the inequality symbol. Alright, that's kind of the only key difference. Everything else we're going to do is pretty much the same exact thing. We're going to use inverse operations to get x by itself. The other thing you can see, we have lines underneath each, like right here. We're going to graph all of these lines. We're going to graph the inequalities. All right, let's look at the first one. The number 1 is very, very easy. You only have, I'm going to separate, right? I draw the line down from the inequality symbol just like we did with an equal sign. Well, if I'm adding 4 to x, I just do the opposite. I subtract 4. That cancels. Subtract 4 from the right. So I have x. Now instead of it equal, I have less than or equal to. Now this right here, 9 minus 4 gives me 5. And that's it. That's my solution. Now make sure, don't just leave 5 as your answer. It's not an equation. An inequality, you get infinitely many solutions. Well, what do I mean by that? Well, let's graph it. Okay, let's put 5 in the middle. Let's put 2 numbers to the right, 6 and 7. 2 smaller numbers to the left. Let's put 4 and 3. Okay. Now, it's underlined, so that means it's also equal to 5. I'm going to put a closed circle. So 5 is a solution because it's equal to 5. Then this is read, x is less than or equal to 5. Well, numbers that are less than or equal to 5, I would shade everything to the left. So really, 5 is a solution to this, 4 is a solution, 3. If I kept going to the left, 2, 1, 0, -1, -2, -3, all the way to -infinity. So that's what I mean. You don't just get one answer, 5. You get 5 and everything here to the left. All right. Let's move to number 4. Okay, number 4, again, it's just a one-step inequality. Now I look at the right side. It's negative 11 times x, so I divide both sides by negative 11. And 33 divided by negative 11 is negative 3. And here the negative 11's cancel out, so it's just x. Now, I went to number 4 for a reason. This is the rule. This is the one difference. I divided both sides by a negative, divided by negative 11. This is where I have to change the inequality symbol. So instead of this open part facing the left, now it's going to face the right. So this is what it looks like. Now the other thing I'm going to do, you always want to have x written first. So let's rewrite it so x is written first. So you might think we're actually changing the inequality symbol, but we're not. The open part's still going to face the x. This is the same thing as this. Okay, look, the open part is still facing the x in both situations. But this is going to help us graph. When we want to graph it, always put x first. Okay, let's put negative 3. Make sure to put this in order. If I go to the right, I'm going to have negative 2, negative 1. If I go to the left, I have negative 4, negative 5. They're less than negative 3. Now, it's not underlying the inequality symbol, so I'm just going to put an open circle over negative 3. And this is read as x is greater than negative 3, so I shade everything to the right. Reason why I put the x first, I can use this trick. This inequality symbol here is pointing to the right, so therefore I shade everything to the right. Okay, the rest you can do on your own. So 3, 5, and 6, finish those up right now. You can stop the video. I'm going to go to the second page, which goes over two-step inequalities. All right, here we go. Two-step inequalities. Let's do number 7. Number 7. All right, I'm just working with the left side. Now, this should be automatic. Remember when this was equals, you know what to do here. It's like you could do this in your sleep right now. You're going to subtract 5 from both sides. That cancels. Subtract 5 from the 21. The only thing I have left with on the left side is 4x. Let's put the inequality symbol greater than. Now this 21 minus 5 is 16. Then, since it's 4x, we divide by 4. And I keep the same inequality symbol because I'm dividing by positive 4 on both sides, not negative. So this is still greater than. 16 divided by 4 is 4. So this is it. This is our answer. Now let's graph it. Let's put 4 in the middle. Let's go 5, 6. A couple smaller numbers to the left, 3 and 2. The inequality symbol is not underlined, so it's an open circle. It means 4 is not included in the solution set. And it's read as x is greater than 4, so we shade to the right. All these numbers are greater than 4, 5, 6, 7, 8, 9, and so on. Okay, let's do one more. Let's do number 9. Okay, number 9, you can see you have, as I always call it, those flashing lights. You have the parentheses. You got to get rid of that first. So we're going to distribute negative 3. So I put my little arrows there. Negative 3 times x is negative 3x. Don't forget to distribute to the negative 4. So negative 3 times negative 4 is positive 12. So I put plus 12. Then I drop everything else down. Greater than or equal to 0. And once again, just like the last one, we have 2 steps now. We're going to subtract 12 from both sides. So we have negative 3x is greater than or equal to 0 minus 12 is negative 12. Okay, then the very last step, since it's negative 3 times x, we divide both sides by negative 3. Now, here I have to switch to inequality symbol. Don't forget about that. I divided both sides by a negative. You could also tell in the beginning, see how you have negative in front of the x? So eventually you're going to have to get rid of it. So think ahead. Be like, all right, there's a negative in front of the x. So eventually I'm going to have to get rid of, or eventually you're going to have to switch to inequality symbol. So this greater than or equal to changes to less than or equal to. These two negatives here cancel each other out. So 12 divided by 3 is 4. So again, let's graph this as a piece of cake. 4, I go 5, 6, just very similar to the last one. 3 and 2 to the left. Now it is underlined here, so it's a closed circle. It means 4 is a solution. And then it's less than or equal to 4, so I shade everything to the left. Alright, so that's pretty much it. As far as solving everything, guys, this should be review for you. Okay? If you can solve an equation, and a lot of you guys did very well on that, this should be a piece of cake. Just don't forget when to reverse the inequality symbol. Okay, all the other ones that we didn't do, I think there's 5 problems I didn't do on the front and back. Do those right now. Okay? So have that done for class tomorrow. Later.